Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today we will discuss about friction topic. The friction is a very important parameter in engineering tripology. So today's session we will see the question bank related to the friction topic. So which type of questions they will ask in the examinations we will see. We will discuss with the question and answers. So the topic is friction and types of friction. So in this, the first one is discuss various types of friction with suitable examples. So how many types of friction are there, and then what are the examples for each type of friction? The friction is the resistive force that occurs when two surfaces interact. Already you know this definition. How discussed in earlier sessions. There are several types of friction, each with distinct characteristics and examples. So whenever two surfaces are in contact, so there is a friction due to the many parameters like surface irregularities and a pure lubrication. So like that. So the type of frictions are one is static friction. So the static friction definition is static friction is the force that resists the initiation of a sliding motion between two surfaces that are in contact at rest relative to each other. So whenever the two surfaces are in contact at rest position, so that in this case the static friction will be developed. Example, when you try to push a heavy box on the floor, so it doesn't move initially due to static friction. The force you apply must overcome the static friction to set the box in motion. So that is comes under this static friction. Next one is kinetic friction. So that is the sliding friction. So the definition is kinetic friction occurs when two surfaces are sliding past each other. It is usually less than static friction. Example for this sliding friction. Once the box starts moving after overcoming static friction, the force resisting its motion is kinetic friction. This is why it is often easier to keep the box moving once it starts. So, already we have seen in static friction example, the box starts moving after overcoming static friction. At rest position, it is in static friction. So whenever we apply force on this box, so there is overcoming this static friction. So that friction is called a sliding friction. So to keep the box moving once it starts. Next, rolling friction. So rolling friction is the force resisting the motion when a body such as a ball or tire or wheel rolls on a surface. It is typically much smaller than both static and kinetic friction. So a bicycle or car tire rolling on the road experiences rolling friction. So example for this rolling friction is bicycle or car tire. This is why wheeled vehicles are much easier to move compared to dragging the same object. So whenever the object is having wheels, it is easier to move when compared to the dragging the same object. So that is rolling friction. This value is very less value than the static friction and kinetic friction also. Next, fluid friction. So that is viscous friction. So as per definition, the fluid friction occurs when an object moves through a fluid, that is liquid or gas. It depends on the object's speed, the fluid's viscosity, and the object shape. Example for this fluid friction, a swimmer moving through a water experiences fluid friction. Similarly, an airplane flying through the air encounters air resistance, which is a type of fluid friction. One is a swimmer example, another one is airplane flying through the air, encounters the air resistance. Whenever the object travels through, moves through a fluid, it may be liquid or gas. That is comes the example comes under this fluid friction. Next, what is this internal friction? Another type of friction. In internal friction is the force resisting motion within a deformable body. It occurs due to the internal movement of particles within the material. So resisting motion within a deformable, deformable body. So it occurs due to the internal movement of the particles. Whenever the force is acting on this body, so internally some particles moving. So that is due to the within the material. So due to this movement, the internal friction will be developed. Example: when you squeeze a rubber ball or resist, you feel is due to internal friction, as the rubber's molecules resist deformation. Next, skin friction. What is this skin friction? Another type of friction is skin friction is a type of fluid friction specifically related to the friction between a fluid and the surface of a solid object moving through it. Example, the drag experienced by a swimmer's body moving through water is partly due to skin friction. Similarly, the surface of an airplane wing experiences skin friction as it moves through the air. So this is an example for this skin friction. Next, compare two examples on a static versus kinetic friction. When you push a stationary car, the resistance you feel before the car starts moving is due to static friction. This is static friction example. Another one is the kinetic friction example. Once the car is moving, the resistance to feel is kinetic friction. And then rolling versus sliding friction. Rolling a heavy barrel is much easier than dragging it across the floor because rolling friction is significantly less than sliding friction. Fluid versus rolling. A ship moving through water, that is fluid friction. It faces different resistive forces compared to a train moving on tracks, so that is rolling friction. Next, outline thermal concentrations in sliding friction. What are the thermal concentrations in sliding friction? So thermal concentrations in sliding friction are crucial because the interaction between the sliding surfaces can generate significant heat. This heat can affect the performance, efficiency, and the lifespan of the components involved. So here are key thermal resistance in sliding friction. So whenever two sliding surfaces contact each other, there is a generation of heat. So sometimes this heat, suppose if heat is generation of heat is very more, so it will affect the performance and efficiency and lifespan of the components. So that's why you have to consider this thermal effect in sliding friction. Some thermal considerations are shown here. One is heat generation. So when two surfaces slide against each other, friction converts kinetic energy into thermal energy, causing an increase in temperature at the contact interface. Example, in a car's braking system, the brake pads sliding against the rotor generate heat which must be managed to maintain braking efficiency and avoid damage. Temperature rise. So the generated heat raises the temperature of the sliding surfaces. The rate of temperature rise depends on factors such as sliding speed, applied load, material properties, and contact area. Example, in machinery, gears sliding against each other can experience a temperature rise, especially under high loads and speeds, leading to thermal expansion and potential misalignment. So, due to these reasons, the temperature rise will be occurred. And then material properties. The thermal properties of the materials involved such as thermal conductivity, specific heat, and thermal expansion coefficient. The expansion coefficient and the specific heat and thermal conductivity influence how heat is distributed and dissipated. So how much heat generated and how much heat is dissipated to the surroundings. Metals with high thermal conductivity like copper dissipate heat quickly, while materials with low thermal conductivity like ceramics retain heat, affecting the temperature distribution. Thermal expansion. So as the temperature of the sliding surfaces increases, materials expand. So whenever the temperature of the sliding surfaces increases, so there is a expansion in the materials. So differential expansion between the two surfaces can alter the contact area and pressure distribution, impacting friction and wear. Example here shown in engines, pistons and cylinders expand differently with temperature changes. The piston moves inside a cylinder from top dead center to bottom dead center. Again, bottom to top dead center. So during this motion, if there is any temperature rise changes, so definitely the piston and cylinder material will expand, which must be accounted for in the design to avoid excessive friction and wear. So that's why the lubrication, proper lubrication is required. So this lubrication oil will absorb the heat from those materials and dissipate it to the surroundings. So next, lubrication. So lubricants are used to reduce friction and wear by forming a film between sliding surfaces. However, high temperature can degrade lubricants, reducing their effectiveness. Example, in high temperature applications such as turbines, specialized high temperature lubricants are required to maintain lubrication effectiveness and prevent metal to metal contact. So it prevents metal to metal contact. So example, happen this type of metal to avoid the metal-to-metal contact case in hydrodynamic lubrication. Next, wear and tear. The elevated temperatures can accelerate wear and tear of the sliding surfaces. This is due to thermal softening, oxidation, and changes in material hardness, leading to increased material loss. Changes in the materials and thermal softening, and all these leads to increase the material loss. So, example, bearings operating under high temperatures. In mechanical engineering, the equipment, the bearings operating at high temperature can experience accelerated wear, necessitating more frequent maintenance or replacement. So, thermal stress and fatigue. So, repeated heating and cooling cycles can induce thermal stress and the fatigue in materials. So, this can lead to micro cracks, surface degradation, ultimately failure of the sliding components. Example, in aerospace components, where sliding friction is common, thermal fatigue can significantly impact the reliability and lifespan of parts, requiring careful material selection and design. So this is very important thing in tribology subject. Next, cooling mechanism. In cooling mechanism, the effective cooling mechanisms such as pins, heat sinks, fluid cooling are essential to manage the heat generated by sliding friction and maintain optimal operating temperatures. Example for the cooling mechanism, high performance racing cars, brake systems are equipped with ventilated rotors and cooling ducts to dissipate heat generated during braking and prevent brake wear. Next, thermal conductivity of surface coatings. The surface coatings with high thermal conductivity can help distribute and dissipate heat more effectively, reducing localized heating and associated thermal effects. Example, coatings like titanium nitride on cutting tools enhance thermal conductivity, allowing heat to be carried away quickly and extending tool life. Next one is frictional heating and energy efficiency. So, frictional heating represents an energy loss in mechanical systems, minimizing this heat generation through material choice. The surface treatments and lubrication can improve overall energy efficiency. Example, in electric motors, reducing frictional heating in bearings and other sliding components improves energy efficiency and reduces the cooling requirements. Next one is describe various loss of friction. So, what are the loss of friction connected with this tribology subject? Friction is the resistive force, already you know, that acts between the two surfaces in contact, opposing their relative motion. So, various laws govern the behavior of friction, and then these can be categorized into two main types: static friction and kinetic friction. Here are the key laws and principles related to friction. A laws of static friction. First law, static friction, law of limiting friction. So here the force of static friction is directly proportional to the normal force. So we can write this equation, the static friction less than or equal to mu n. Mu is here coefficient of static friction. Similarly, the second law of the static friction, here self-adjusting nature. The static friction adjusts itself to be equal and opposite to the applied forces up to its maximum limit. It means if no external force is applied, the static friction is zero. As the external force increases, static friction increases proportionally. So until reaches the maximum value of mu Sn. Next law of kinetic friction. The first law of kinetic friction proportional to normal force. Already have explained here. But this is kinetic friction. Mu k is the coefficient of kinetic friction, which is typically less than the coefficient of friction. And the second law of kinetic friction independent from velocity. So the object is in motion, the kinetic friction remains constant regardless of changes in speed. Next, the list role of sliding friction in industries. The sliding friction. So, what is the role of sliding friction in this industries? One is machining and manufacturing. It affects the both efficiency and performance. The tool workpiece interaction and the material handling sector. It is impacting the efficiency of material handling systems. In automotive industry, the braking systems and clutches and transmissions. It will affect on these equipments. In textile industry and production and fabric finishing and food processing units of packaging, sliding friction affects the movement of packaging materials and products on production lines, influence the efficiency and speed of packing operations, the cutting and slicing. So these are the role in industries, in construction industry, heavy machinery and building materials. So the operation of excavators, bulldozers and other heavy machinery affecting their movement and stability on the different surfaces. So that's why the sliding friction is a factor in the operation of this machinery in building materials. So bricks and tiles during handling and installation influences the ease of construction and the integrity of the structures. In the case of mining and mineral processing, ore crushing and grinding, conveyance systems, and energy sector, wind and water turbine, and pipelines. So, in wind and water turbines case, sliding friction is in bearings and gears of turbines affects their efficiency and lifespan, impacting the overall energy output. In pipelines, the friction between the inner surface of pipelines and the flowing fluids affects the pressure drop and energy consumption in transporting oil, gas, or water. In aerospace industry, already we have discussed in the previous sessions, the landing gear. The aircraft's landing gear and runway during landing and takeoff is crucial for safe operations. So the moving parts, friction in the moving parts of aircraft engines and control systems affects the performance, efficiency, and maintenance requirements. In the case of electronics and operation equipments, assembly and operations, heat dissipation in electron events must be managed to prevent overheating. And the sliding friction is important in the assembly of electronic components and the operation precision instruments influence their reliability and accuracy. So the pharmaceutical industry, tablet manufacturing sector and the packaging and distribution unit, when a mixing processing of mixing, compressing and coating tablets, affecting the uniformity and quality of pharmaceutical products. The packaging and distribution, the movement of pharmaceutical products through packaging lines and distribution channels is influenced by friction, impacting efficiency and product integrity. So next one is explain briefly about the dry friction. So dry friction already, as per definition, it resists the initiation of sliding motion between two surfaces. So it can be categorized into two types. One is static friction and another one is kinetic friction. So here also known as the Coulomb friction. The characteristics are It acts where when there is no relative motion between the surfaces. It increases with the applied force up to a maximum value known as the limiting friction. Once you apply the force exceeds the limiting friction, motion begins. So the static friction you can write like this: static friction less than or equal to mu multiplied with n. Here mu is the static friction, then is the normal force. Whereas in kinetic dynamic friction, you can write Fk is equal to mu kn. It adds there is a relative motion between the surfaces. The factors affecting the dry friction, nature of materials, and surface roughness, and normal force, surface area, temperature. These are the factors affecting the dry friction. So applications and examples. So what are the applications of dry friction? The braking system and walking, human locomotion depends on the static friction between the feet and the ground. And similarly, mechanical device and machining. Explain briefly about fluid friction. Fluid friction already we have discussed in starting slides, where there is a fluid move relative to each other. It resists the motion of the objects and flow within the fluid, or it may be gas or liquid. The characteristics of fluid friction is dependence on velocity and laminar flow. It's described by Stokes law, 6 epsilon RB. The turbulent flow, fluid motion is chaotic, and fluid friction increases more sharply with velocity. Viscosity measures the fluid resistance to deformation and flow. The higher viscosity means the greater fluid friction. Factors affecting the fluid friction are fluid viscosity, velocity of object fluid, and surface area, and shape and flow region. Examples and applications are air resistance, water resistance, pipes and channels, and lubrication. Semi-fluid lubrication, semi-fluid friction. So already we have seen fluid friction. Semi-fluid, known as mixed or boundary lubrication, occurs when a thin layer of lubricant exists between two sliding surfaces. So where no lubricant is present, that is in the case of dry friction. This type of friction represents a transition phase between the fluid friction. In semi-fluid friction, contact and lubricant role and conditions and applications are major parameters. So these are the references I have taken for this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.